We're now going to do a dimensional analysis problem from space science. One of the greatest challenges that students face is actually just reading the problem and trying to figure out what is being asked. This is a fairly long problem, but let's go through it so we can see the challenges that students may have. So, on June 19th, 1976, the United States successfully landed Viking 1 on the surface of the planet Mars. 20 years later, on July 4th, 1997, NASA landed another robotic probe named Mars Pathfinder at a distance of 520 miles from the Viking 1 land site. So we have a value here, the distance of 520 miles between Mars Pathfinder, which is the new probe, and Viking 1, which is the old probe. So we're going to put V here for Viking, and we're going to put P here for Pathfinder. And we know now that there's a distance between these of 520 miles. Okay, so this is our known value here. 520 miles is the distance between those two. Unlike the Viking mission, the Pathfinder included a surface rover known as Sojourner. So Pathfinder had a surface rover that could move across the surface of Mars. That's what it's saying. And knowing that the distance between the landing site and the Mars Pathfinder and the Viking craft is 520 miles, as stated before, what would be the minimum number of hours required to drive Sojourner to the Viking craft, assuming a top speed of 0.70 centimeters per second? So you're going to have a vehicle that's going to be called Sojourner, and Sojourner is going to travel from Pathfinder to Viking. So Sojourner is making this distance. Let's assume it's making that distance. We know that it has a top speed of 0.7 centimeters per second. So we know that the speed of it, the speed of Sojourner, is equal to 0.70 centimeters per second. So that is going to be another known here. Top speed of 0.7 centimeters per second. So we're assuming an ideal condition here. We're saying that if it's traveling at this speed here, what's the minimum number of hours that could be required to drive there? So our unknown in this case is going to have to be the number of hours or the time required for Sojourner to move from Pathfinder all the way back to Viking. So now we can write this down. We can say that, okay, the thing we're trying to determine here is the number of hours. In other words, if we have anything in units other than numbers of hours, we know we've done things incorrectly. We know that the speed of Sojourner is 0.70 centimeters per second, and we need to figure out what the time is to go a distance of 520 miles. So we know that our distance is 520 miles. So we can see here that we have different units. We have expressed in metric units, centimeters per second, and then we have here in English units or customary units of 520 miles. So obviously it's going to require some kind of conversion. So here's where somebody would need to look up what those conversion factors are. And one of them is that there's 5,280 feet in a mile. Well, since a mile equals 5,280 feet, we could say that's equal to 1. So this is a unit, or basically if I can multiply by 5,280 feet per mile, or divide by that same value, it's not going to change the answer because it's going to be multiplied or divided by 1, which will be the same thing. So this is going to be another known. We know that we have to get here to centimeters, so we need to figure out some other kind of conversion factors. Well, looking in the table or just online, you're going to see that there's 2.54 centimeters approximately is equal to 1 inch. Or we could say that there's 2.54 centimeters in an inch, or they're the same thing, so that's also equal to 1. Now, this is feet and this is inches, so there's one other thing we need to figure out here, and that is that there's 12 inches in a foot. So the next thing is to draw our dividing line, and we know that the answer to this particular problem has to be expressed in hours. And so we'll say equals hours, and we need to figure out how many hours that's going to be. So the first thing we're going to have to do is we're going to have to put in some kind of a time variable. So we're looking at this. These are going to be distance, 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 distance. We have speed, which is 0.70 centimeters per second. So now we have a time value in here in seconds. So because time is in the numerator here, we're going to have to divide by this, or we're going to say that there is 0.70 centimeters per second is the speed. Now we have time in the top. All we have to do is we have to cross out distance here. If we can cross out distance, then convert seconds to hours, time to time, will be fine. Well, we do know that there's 2.54 centimeters per inch. There's a centimeters here and a centimeters there. So we can say there's 2.54 centimeters per inch. At this point, we can say that centimeters cancels. And so we now have values of seconds per inch, which is kind of a strange value, but it's just the inverse of the speed that it's traveling in inches per second. So looking at this, we know that inches is now in the denominator, which we need to get rid of if we're going to be able to work this out. And so we can multiply by the fact that there is 12 inches per foot. Again, since that's equal to 1, I can either multiply or divide by it. In this case right here, we'll see that inches will cancel, and now we have values of seconds per foot, or the inverse of how many feet per second it's traveling. Well, now we look at this and say that there's 5,280 feet in a mile. If I'm going to cancel out feet, I must multiply by this value, so 5,280 feet per mile. Again, I can either multiply or divide by it because it's equal to 1 as well. In this case, I'm choosing to multiply by that value. And so we can see here that feet cancel out. And so now we have how many seconds per mile, or the inverse of its speed in terms of miles per second. And now we know that the distance here is simply 5,280 miles. I'm sorry, 520 miles. So let's put that in here. 520 miles. And now miles will cancel. And when miles cancel, we now have seconds and hours. So all we have to do is we have to convert from seconds to hours. Well, there's 60 seconds in a minute, 60 minutes in an hour. So we know that there are 3,600 seconds is going to be in 1 hour, and so that's also going to be a value of 1. So now we can multiply or divide by this as we need to, because it won't change our answer. In this case right here, we need the seconds in the denominator, so we have to divide. So it's going to be 3,600 seconds per hour. And now our seconds cancel, and we have value of hours. And so from here, it's simply a matter of multiplying everything in the numerator, dividing everything in the denominator, and that will be our answer. Now again, it's always best to estimate in your mind. It's good to do this with using scientific notation. And so we can do that right here if we want to. This is approximately equal to 1, roughly speaking. Okay, so we can say that that's going to be equal to approximately 1. So if we're to look at that, that's going to be 1 there. This is approximately, well, 2 or 3, we'll just call it 2. So there's 1 and there's a 2 in the numerator. This is approximately 10, or 1 times 10 to the first. 5,280 is approximately 5 times 10 to the third. 520 is approximately 5 times 10 squared. 3,600, we'll call it approximately 4 times 10 cubed. Okay, so approximately 4,000. So the first thing we can do is just get rid of the exponents. So on the top it's 10 to the first times 10 to the third, so that's going to be 10 to the fourth. We can just add exponents, times 10 squared, which is going to be 10 to the sixth. This is going to be 10 to the sixth divided by 10 to the third. So we know that our value here is going to be in units of 10 to the third, okay, because there's 10 to the sixth in the top, 10 to the third in the bottom. Then we just look at the numbers. 2 times 5 is 10, times 5 is 50, divided by 4, which is approximately 10. So it's approximately 10 times 10 to the third, or the value is going to be about 10 to the fourth. So now we just simply do the math to confirm this, or to check to see if we are. When we do so, our value comes out to be 33,208 hours, and that's again our value is what we expected, 10 to the fourth. We could express that as approximately 3 times 10 to the fourth, which was the range that we had predicted, and so we know that we have a reasonable measure. So looking back here, we can see here that we were looking for number of hours before. We now have determined our number of hours right there. Our estimate, based on our calculations before we put things in the calculator, was in the right order of magnitude as our answer, and so we can be fairly confident we've done things correctly.